Hi folks, in the last short video I discussed with you the boost converter, and before that I discussed with you the buck converter, and I told you that in the buck converter the output voltage is always less than the input voltage, whereas in the boost converter the output voltage is always higher or larger than the input voltage. Today I want to discuss with you another non-isolated version of the switching power supply topology, which is called the buck boost converter. As the name suggests, in the buck boost converter the output voltage can be either higher than input voltage or can be lower than the input voltage, and it depends upon the duty ratio. I mean the amount of time when the inductor is charged. uh, the basic building block of the buck boost converter is the same, as long as the components is count is concerned. I mean there is an input capacitor, and then there is a series switch, and then there is the output rectifying diode and the output capacitor, and the inductor is connected one point to the switching node and other point is connected to the common ground. Uh, as long as the selection of the components of the buck boost converter is concerned, the inductor is selected according to the peak value of current that we have to pass through it, and the peak current depends upon the two components. One is called the AC component and other is called the DC component. The AC component of the current is maximum at the maximum input voltage range, which is similar to the buck converter, but the DC component is maximum at the minimum input voltage range, and the DC component is larger than the AC component, so we normally select the inductor of the buck boost converter at the minimum input voltage range. As long as the output capacitor and the input capacitor are concerned, they are also selected at the minimum input voltage range. And similarly the MOSFET is also selected at the minimum input voltage range, because the RMS current is maximum at minimum input voltage. The diode is in series to the output path, so its current is the same as current drawn by the load. We select the diode according to the output load requirement and the load current requirement. The buck boost converter, although as I told you that the output voltage can be higher or lower than the input voltage, but the important thing is that the output polarity is reversed. I mean, if the buck boost converter is configured with the positive input voltage, then the output voltage will be negative. As an example, suppose that input voltage is 5 volt and we want to get the 10 volt output, then although input voltage is plus 5 volt, but the output voltage will be minus 10 volt. Similarly, the buck boost converter can also be configured with the positive output voltage, but the input voltage would be negative in that case. I mean, as an example, suppose that input voltage is minus 20 volt and output voltage would be plus 5 volt. Only the magnitude would be higher or lower than the input voltage, but the polarity would be reversed. So concluding, the buck boost converter is the step up and step down converter at the same time, and it depends upon the duty ratio. However, although the magnitude is can be higher or lower than the input voltage, the output polarity would be reversed. If the input voltage is positive, we can configure the buck boost converter only in such that the output would be negative. Similarly, if the input voltage is negative, we can configure the buck boost converter only, so that the output voltage would be positive. This was today's short video. So stay connected and thank you very much.